Okay, so this video is on determining the true shape, or determining the projections of an object that has been cut by an oblique plane. So let's first of all analyze this object. So it's a square base prism that is upright, so it's at 90 degrees to the ground, or our XY line in elevation. We can see the vertical and horizontal traces, so we have the vertical trace and we have the horizontal trace in plan. We need to determine what this elevation will look like when this is cut. Because this prism is the same width or the same length the whole way up, so it doesn't get narrower, it doesn't get wider, we can see the cut surface here. Now it looks as if nothing has happened in plan because we can't tell that it has been cut at an incline. So we need to first find the 4 points up here. So we're going to have 1 point here. I'm going to call this number 1, 2, 3 and 4. Number 1 will be along this edge here somewhere. I don't know how high up yet. 3 will be along this hidden detail edge because we're standing down here. We can't see that back edge. 2 will be on the left and 4 will be on the right. So first of all, I'm going to find point 2 because it's closest to my horizontal trace. We're going to first use horizontal cutting planes as it is here. So label the vertical and horizontal traces, done. Index the prism, I've done that. Now I need to determine the projections of the prism that has been cut by the oblique plane using horizontal cutting planes. Horizontal cutting planes being the key word here, it's going to mean that we're going to have horizontal planes here. So where I find point 2, point 2 is going to lie along a horizontal line that cuts this edge here somewhere. I don't know where just yet. Because this will be a horizontal line in elevation, in plan it's going to appear as a true length line, which will have to be parallel with our horizontal trace because that is also a true length line. So this horizontal line up here that we don't have yet will appear parallel to this line here. So working backwards using that information, if I just get a ruler here, I'm going to use my sliding set squares. Now this is set up to, I think it's 60 degrees if I remember. So you can use your T-square if you have this set up. I'm just going to use sliding set squares. I'm going to use a red pen to indicate this. So I'm going to bring point 2, first of all, parallel to the horizontal trace because it will be a true length line in plan. Now that it hits here at the XY line, it means that it's on the vertical plane. So the vertical plane being the upright plane that we can see behind this object. That upright plane appears as the XY line in plan, and in elevation the vertical trace is on that upright plane because that is the point or the line of intersection between our oblique plane and the vertical plane. So that point doesn't move left or right now, it moves vertically up until it hits the vertical trace because that is where it lies. So that is the altitude that that point is at. So remember, we're using horizontal cutting planes, so point 2 has not changed height. It's basically just moved from right to left for now. So at this angle, but in elevation it's going to appear to move from right to left. So now we have it here, which is basically the same point. We're going to move it back to lie upon its original line. So if I use my sliding set squares here again, you can use your T-square. I'm going to pull it back onto the edge it needs to lie on, and we have found point 2. Obviously if I didn't have this object constructed, I would need to construct a vertical line projecting up from point 2, and that would give me now point 2. It's the same method for all other points. So again, parallel to our horizontal trace, project up to hit your XY line, and coincidentally this just hits here at point 2, so it's going to be somewhere along this line. So we project it up to hit our vertical trace like we did over here. So let me just draw in some arrows. So across, up, back, and then up to meet. Here we have across, we're projecting it up. We then need to project it back, and then up to meet. And I found point 1. find point 3 and 4 is the exact same method. Up to hit the XY line, up to hit the XY line. I'd recommend doing this one at a time, just so that you don't get confused with all the different lines. So up to hit the XY line, bring it up vertical to hit your vertical trace. Up to hit your VT. Up to hit the VT. And then back across to where it needs to lie, so onto its correct edge. So again, point 4 will be on the right hand edge, and point 3 will be on the hidden detail edge. Point 3 is just here. Point 4 just there, and if I project up, you'll see how that matches up. To there and up to there. So if we index all those now, 4, 3, this is 1. We have our 4 points of our surface. We can join them up now. So 1 to 2, 2 to 3. If you're unsure the method or the direction to go up, look in your plan. So 1 joins to 2, which I've done. 2 joins to 3. 1 also joins to 4. And 4 joins to 3. This is also a good example that shows you that parallel lines remain parallel. So 1 and 4 is parallel to 2 and 3. 1 and 4 is parallel to 2 and 3. 2 and 1 is parallel to 3 and 4. And you can see that they're parallel. And now we have the cut surface shown here. The other side of this worksheet is very similar, except this time it asks us to use vertical cutting planes. All that means is, when we use vertical cutting planes, in our plan we will see horizontal lines, and in our elevation we're going to see lines parallel to our vertical trace. So I'm just going to use a pencil this time. I'm going to label my VTH. I'm going to index my points the exact same way, and this should appear the exact same as over here. So first off, horizontal line, so we need to project all 4 points this time, not horizontally in elevation, horizontally in plan, or parallel to the XY line in plan for the correct term. The reason we do this is so that they appear as true lengths in elevation, and because we have the vertical trace, which is also a true length, it will be parallel to that vertical trace. So I'm going to project over the 4 points. We're going to now project them up to hit the XY line vertically, so thinking about backwards to what we were doing here. So we've currently hit our trace, now we're going to bring them vertically or perpendicular to our XY, and then we'll go parallel to our vertical trace. So where they hit the horizontal trace, bring them up, and then we're going to go parallel. So we have 1, 2, 3 and 4 points. We're going to go parallel to our vertical trace here now. So we have our 4 projection lines. I'm going to follow them one by one. So 3 comes across to here, up, back up, and 3 lies on the hidden detail line, which is just there. 4 goes to the right hand edge, which is just here. 2 goes to the left hand edge, which is just there. And 1 goes to the middle. I have all my 4 points now, so I'll just index them again. This time I'm going to use a blue marker to index them. The reason I didn't use colour pen is just so that it didn't confuse too much. So I have point 1, point 4, point 3 and point 2. Like before, just join them up. surface. Quite similar to this. Don't know if they're exactly identical. Just do a quick test here with point number 4. They should be the exact same altitude if it's 100% accurate. And they are. So that's those two exercises. Hopefully that helps. For the next exercise, the cylindrical one, it's the same method, just practicing with curved solids as well. And hopefully this helped. Thanks.